Hey there and welcome. Today we're going to decode a secret language that you actually use every single day, and you might not even realize it. We're talking about directed numbers, a really simple but incredibly powerful way to make sense of our world with total precision.
So, just think about it for a second. Numbers are awesome for counting things, right? But what about describing which way something is moving or whether something is changing for the better or worse? How can just one number tell you if you're going up or down, gaining or losing? That is the big question we are unpacking today. Our whole world is basically built on these opposing ideas. The temperature goes up or it goes down. You have money coming in and you have money going out. Just using regular old numbers, well, it can't really capture both sides of that coin. We need something more. And that something more has a name. So let's dive into the language of direction and introduce directed numbers. The concept itself is beautifully simple. Directed numbers are really just your everyday numbers, but with an extra piece of info, a sign that tells us their direction. It lets us talk about not just how much of something there is, but the nature of that amount. And it all comes down to three basic building blocks. First, you've got your positive numbers, with a little plus sign, that represent one side of things. Then you have the negative numbers with a minus sign for the total opposite, and smack dab in the middle, you have 0. That's our neutral starting point. All right, that's enough theory. The absolute best way to get a feel for this language is to see it out in the wild. Let's look at a few real-life situations where you're already using directed numbers all the time. Okay, first up, a simple elevator. It's basically a perfect number line that goes up and down. We can just decide that the ground floor is our neutral 0. So anything above that is one direction and anything below it is the other. Simple. So let's put this to the test. If you get on at the 3rd floor and ride all the way up to the 10th, how would you describe that entire trip with just a single directed number? Now remember, think about both how far you went and which way. Exactly, it's positive 7 floors. The number 7 tells us how far, 7 floors. But that little plus sign, that's the real key here. It tells us the direction was up. If that said -7, you would instantly know you went down 7 floors. So cool! Now, let's take that same exact logic and apply it to something totally different, your money. We can just decide that a deposit, so money coming into your account, is a positive thing. Okay, so if putting money in is positive, what about the opposite? Let's say you take out or withdraw $500. How would you write that down so that anybody looking at it knows exactly what happened? You got it. It's negative $500. That minus sign immediately tells you that money left the account. It's the polar opposite of a deposit. See how clear and efficient that is? This whole idea also works for physical space and direction. Think about a compass. We can just assign positive and negative values to it. So for this example, let's say that moving east is our positive direction. All right, now for a slightly tricky one, you walk 200 meters to the east. How would you write that down based on our new rule? But pay very close attention to that hint there. The unit we need is kilometers. That little detail is going to be super important. And there we have it, plus 0.2 kilometers. The plus sign shows we went east, which we decided was our positive direction. And the 0.2? Well, that comes from converting 200 meters into kilometers. We can even use directed numbers to compare things. So check out this table. It's not showing the students' actual heights. Instead, it shows how they stack up against the class average. A plus sign means they're taller than average, and a minus sign, well, you guessed it, they're shorter. So with that information, do you think you can figure out student B's real height? We know the average is 160 centimeters, and we can see that student B's directed number is -4. So what's the final height? And the answer is 156 centimeters. The -4 tells us that student B is 4 centimeters shorter than the average. So all we have to do is take 160 and subtract 4. Boom, 156. Simple, precise, and super clear. Okay, so we've gone from elevators to bank accounts to height comparisons, and all of these examples really follow just a few basic principles. So let's boil it all down into 4 key rules you can use pretty much anywhere. Think of this as your master key. Okay, rule 1, the symbols are the whole story. Plus and minus tell you which way you're going. Rule 2, 0 is your home base, your neutral starting point. 3, and this one's a biggie, keep your units consistent. We saw what happened with meters versus kilometers, right? And finally, number 4, context is king. A +5 could be $5, 5 floors up, or 5 degrees warmer. It all depends on the story you're telling.
Look, at the end of the day, this isn't just about math. When you really get the hang of this language, you unlock a totally new way of seeing and describing the world around you. It's kind of like a superpower.
And really, that's what this is all about. Directed numbers are a tool, something we humans invented to bring some clarity to a world that's just full of change and movement and opposites. It's this hidden language of relationships, and now you know how to speak it.